Hello everyone, I welcome you on this fine afternoon. This is going to be a short clip. There's not going to be much of an outro. There's not going to be anything. It's not even going to be listed as like a part of a series because this is school stuff. So I'm not doing every single problem because you guys can handle it yourselves. I think it's very easy. It's just this one question that I thought was interesting, so I thought I would show you. And this is number 6 in the Algebra 2 Trig January 2011 Regents. The problem goes a little something like this. It's the absolute value of 4a minus 6 minus 4a is equal to negative 10. I thought this problem was interesting, so I'm going to do it now. The first thing you always do when you do these kinds of things is you have to get the absolute value expression by itself and the value on the other hand. So in this case I'm just going to add both sides by 4a, and that should get rid of this 4a right here. So that's exactly what I'm going to do. I'm going to add 4a here, and add 4a here. And just to make it easier on my life, I'm going to make the 4a precede the negative 10. So it's going to be like this. It's going to go a little something like this. And as you know, absolute value, now we need to set up two equations, one for the positive value and one for the negative value, because both the positive and the negative value are the same thing when we're talking about absolute value. So when we set up two equations like this, 4a minus 6 is equal to positive 4a minus 10, and 4a minus 6 is equal to negative 4a minus 10. This is interesting because we're putting the negative on the binomial itself, not the we're not just sticking the negative on the 4a and not the negative 10, because that wouldn't be equivalent. So in this case, we're going to have a 4a minus 6 equals just 4a minus 10. Nothing's fancy there. But here we're going to have a 4a minus 6 is equal to negative 4a plus 10, because we're distributing that negative across the entire binomial. And that is the important thing, I think. That's the important thing to make sure you get. So here, let's just solve for the a. Here, the 4a's cancel out, and we're left with a negative 6 is equal to negative 10, which makes no sense whatsoever. So we can call this not valid or erroneous, and we can just cross that out from our mind entirely. Here, we can add 4a to both sides and get 8a minus 6 is equal to 10, and we can add 6 to both sides to get 8a 16, and a equals 2 in this case, right? Let's just make sure I did my math right. If I add both sides, and then I add that, we get a equals 2. Alright, so a here is equal to 2, and this solution, this makes no sense whatsoever because the 4a's cancel out, so we're just going to go with this. But we have to plug this back into the equation just to make sure that we have the right answer. So we have a 4 times 2 minus 6 minus 4 times 2, 2, sorry, equals negative 10. Actually, let's just undo that because that just looks kind of messy. So 4 is equal to negative 10. Okay, so we get 8 minus 6 is 2 here, and we get minus 8 here is equal to negative 10. Now we get a negative 6 is equal to negative 10, which, as you can see, is the same thing we got here. They both don't make sense, and they're false. So what we actually end up having here is an absolute value equation with no solution. There is not a solution because all of them are erroneous roots.